Okay, so here we are for review unit 1. We're just going to go through these. I want you to make sure you write anything down that you don't have on your paper that I do. So it needs to be in a different color just to help you go over what you need. Look at number 1. Blake and Abby need to write 6,700,000,000 using scientific notation. Blake claims that it is equal to 6.7 times 10 to the 8th, and Abby claims that it's 6.7 times 10 to the 9th. Which of the following best describes whose number is correct and the reason it's correct? So we're just going to first of all look at which one. Okay, so right here, if we do this, we would put our decimal here, and we would move over 1, 2, 3, 4, 5, 6, 7, 8, 9. And he says it's 8. So we can already tell that Blake is wrong. Okay, so looking at our answers, it talks between Blake and Abby. So Blake's number is correct. No, Blake is not correct. Okay, so also on C, Blake's number is correct, and we know that's not true. So Abby is correct because she has the 9. Okay, so Abby's number is correct when converting 6.7 billion to the decimal would be located between the 6 and the 7, and the power of 10 is determined by the number of zeros plus 1. Well, that does actually work. And so what about D? Abby's number is corrected because when it's converting 6.7, the decimal would be located between 6 and 7, and the original decimal point of the standard moves to the left 9 places. Okay, it's going to be D, and I'm going to tell you why it's not B, okay? It's not B because of this right here. Because not all numbers are like this. It's not always going to be 6.7. What if we had 6 billion, okay? So if we had this, it would just be 9. If you added one more, that would take it above, so it wouldn't be plus 1. So you need to understand that numbers are different, so we can't use that kind of saying, so it doesn't always fit. Okay, so B is not going to be it, and D is going to be your answer. Number 2, the tree diagram represents a relationship between the sets and subsets of rational numbers. So really this is just taking the big diagram we talked about and moving it down a little bit. So you know our big idea was rational numbers, and then we had some subsets in there. So rational numbers then went to integers. Okay, and then you can tell this is whole because of the examples it listed. Okay, so integers are negative, I'm just going to write it kind of shorthand, or positive whole numbers. Okay, so which of the following groups of numbers could be placed in section B? Okay, so we're looking for negative or positive whole numbers. Well, this looks like it. This is a fraction, so we know it can't be this one. There's that fraction in a decimal, so we know it can't be here. This only has negative or positive whole numbers right here, so A is your answer choice. Okay, next page, 3. It says place the numbers in ascending order. Okay, so ascending order means what? Least to greatest, okay, because we're going up. So I'm going to make that little notation there. Okay, we need to convert all of these. So I'm going to convert them to decimals just because that's easier to deal with. So for example, this is going to be negative 3.4. And then we're just going to leave that negative 0.75. Now 9/7. How do we convert that? We can do top in, bottom out, and we can divide. Okay. And so we have 14, 6. So if we keep on going, we would be 5.285. So I'm just going to stop there with 1.28, and then we're going to leave it there. 1 2/9. 2/9 is a fraction. It starts a repeating decimal. So I'll show you that. Okay, it's going to go in there twice, and then it starts repeating that too, if you can see that. Okay, so we're just going to write 0.2 with a bar over it for 1 2/9. Then negative 4/3. I hope you know 4/3. It's 1.3 repeating, and then we have 0.7. So my least number is going to be what I would put furthest on the number line. So it's going to be my smallest or my largest negative number. So I have 3.4. And then I have 1.3 that are negative and 0.75. So I'm going to go with negative 3.4. That's going to be my first one. So 3 and 2/5. So that should be my first number. So A has it, B has it, C does not, D does not. Okay, so that's my first one. My next one is going to be negative 1/3. Okay, so which converted back to negative 4/3. So A does not have it and B does. So then we've simplified out all of our answers. Okay, number 4. Lily estimated it would take 800 grains of sand to make a pound. That would mean that each grain of sand weighs 1/8,000th of a pound. In decimal form, that would be 0.000125 of a pound. Which of the following is the weight of the grain of sand expressed in scientific notation? Okay, remember in scientific notation, our decimal goes right after our first natural number, so which would be 1, and then we would go 1, 2, 3, 4, so it would be times 10 to the negative 4. Okay, and then, so there's our answer, and we don't even need to play around any more than that. Okay. Number 5, which statement is true and represents the correct form in scientific notation? So we're looking for a true-false statement here. So this is saying if we put this in scientific notation, it would be 1, 2, 3, 4, 5, 6, 7. So it looks like that's equal. So this is a true statement here. Let's check the other ones though. So this one would scoot over 1, 2, 3 and make it 930. Well, 930 is actually, this side is smaller than this side, so this is a false statement here. So it can't be there. If you scooted this over, it would be 1, 2, 3, 4. 50,000 is less than 50,000. Nope, they're equal. And then scoot this over. Nope, it goes the other way. Okay, 1, 2, so 0.089. But it's positive, and then this one is negative, so this is a false statement there. So our only true answer is letter A. Okay, number 6. The Venn diagram represents the relationship between the sets and subsets of rational numbers. Analyze the relationship with the Venn diagram to identify the appropriate number sets using each of the following tables. Okay, so we know our big overall set, we talked about rational and irrational, but in one big group it was rational. Okay, and then it went to integers, negative and positive whole numbers. And then it went to whole numbers, including 0, and then it went to natural or counting numbers. Okay, so it actually gives you an example in each in case you have any questions. This little thing skips, so I'm going to skip on over to this one because that's where it should be. So number 7, for 5 days, students measured and recorded the change of water depth in the pond. They measured the following changes. List the days in order from the day's greatest increase to greatest decrease. So the biggest number to the smallest, so G to L. Okay, so I'm going to convert all these. This I know off the top of my head. I know this one. I know this one. So I know some. So my greatest number is going to be 0.33. This one right here is going to be Monday. So if we list the days, it's Monday. And then this is not negative, so I'm just be careful with that. Okay, and then it's going to be Friday. And then it's going to be Wednesday. And then it's going to be Tuesday. And then it's going to be Thursday. Okay, so that takes all of your numbers up as they go. Okay. So we're going to end on this one, and then I'm going to restart a video for the second half.